So hello everyone, let us solve another LeetCode problem, and the problem name is Four Divisors. So given an integer array nums, you need to return the sum of divisors of these integers in that array such that they have exactly 4 divisors. If there is no such integer in the array which has 4 divisors, you need to return 0. So what the question is saying that you are given an integer array nums. For each and every nums value, you need to count how many divisors it has. If it has 4 divisors, you need to calculate the sum of the 4 divisors and add it to your answer. And if you get some again any number which has 4 divisors, you need to again take the divisor sum and add it to your answer. So this is what the question is saying. So let us understand with the help of first and second example. So here the nums array is 21, 4 and 7. So first we need to calculate divisors. So 21 has divisors 1, 3, 7 and 21. It has 4 divisors, so we'll be taking the sum. So sum will be 3 plus 1, 4, 4 plus 11, 4 plus 7 is 11, 11 plus 21 is 32. So we have sum as 32. This is not the final answer. We may get some more numbers which has exactly 4 divisors, so we may need to add something to this as well. So this is the current sum that we have. Now we take to 4. Now 4 has divisors 1, 2 and 4. It is not having exactly 4 divisors, so we'll not be taking the sum. Now we'll be having 7 as the number. So 7 is divisor 1 and 7. So again it doesn't have 4 divisors, so we will not be taking the sum. So only one value we get, that is 21, which has 4 divisors and its sum is 32. So we will be returning 32. Now let us see one more example for better understanding. So this is the second example. Here the nums value is 21 and 21. So we have already seen the divisors of 21 in the previous examples. Its divisors is 1, 3, 7 and 21. So the current sum will be 32 because it has exactly 4 divisors. So for this 21 we have 4 divisors. Again for this 21 as well, it is 21 only, so we will be having the same same divisor sum 32. So we got two numbers which are same having the 4 divisors, so we take their sum and we add it. So we will be getting our final answer as 64. So you can see that's why we are returning 64. Now how will we be solving this particular problem? Let us see. So let us see first how we'll be finding the divisors. So let us say we are finding divisors of this particular number n. So what we will do, we'll be running a loop from 1 up till root n. Now I'll explain why we are taking root n, why not n. But yeah, for now we are running a loop from 1 up till root n. Now we will check whether this particular n is divisible by our particular number I or not. And we are also keeping a divisors array or vector to keep a note what all divisors we have till now. And we will check if this n is divisible by I, that means it is a divisor, so we'll be pushing this I into our divisors vector. So divisors dot pushback I. Now before going on to the forward part, I'll just explain why we are taking root n, because this is linked to this part only. So let us take an example. Let us say our n value is 36. So what all divisors it has? 1, 36, 2, 18, 3, 12, 4, 9 and 6. So these are the divisors of 36. Now if you take root n of in this case n is 36, so you get the root n is 6. So let us say we divide this part. So this is the values before root n and these are the values after root n. So if you see it carefully, if you do 2 cross 18, it is 36. If you do 1 cross 18, it is 36. It is again 36. All of the values are 36. Now all the values that are coming after this root n are the same values that are appearing before root n, but just in the reverse order. So we can say that if we know a divisor within the range 1 to root n, we can also get the divisor which is present after root n. Let me show you how. Let's say we are taking 2 for now. The I value is 2. So if we divide 2 by 36 by 2, we get 18. And if we divide 36 by 18, we get 2. So 2 is before root n and 18 is after root n. So if we divide 36 by 2 we get 18. If we divide 36 by 18 we get 2. So we are getting the numbers in pair before the root n and after the root n. So we can say that if we know a divisor which is present before the root n, we can also get the divisor its reverse pair that is present after root n. How? If we divide 36 by 2 we get 18. So we can say that if we have I as the divisor, its pair will be nothing but n divided by I, because that is how we are getting 18. So let's say we take another example. Let's say we have the I divisor as 3. So this is the I value. So how to get its pair that is present in the after the root n part? So we'll simply divide 36 by 3, we'll get 12. So this is present after the root n part. So this is how we'll be doing. So I hope you understand why we are running a loop from 1 up till root n, because if we know the value of the divisor, if we know the divisor which is before the root n, we can also get the divisor which is present after the root n. So why to loop if we are just able to do it in root n times only? So this is how what we'll be using in the in the explanation part as well. So if I is the divisor, we can also say that n by I is also the divisor which is present after the root n. So we will push divisors dot push back of n by I, but this is not correct. Why? Because if you look at the same example, here we have the value as 6 cross 6. Here I is also 6, and if we divide 36 by 6 we get 6. We get 6 again. So here I and n by I are both same. So we just need to keep a check before adding n by I to our divisors vector. So we will not directly push n by I into our divisors vector. We will add a check. If I is not equal to n by I, then only we will be pushing the n by I to our divisors vector. So divisors dot push back n by I. And after this loop, after we have the divisors array, we just need to check whether its length is 4 or not. If its length is 4, we just need to take sum and add it to our answer. So I hope you understand this part. So let us directly see the code now. It is pretty much simple and easy to understand. So yes, this is the code. So first of all, I am creating a sum variable which will be keeping track of all the divisors sum. So first we are running a loop for the nums array. Let's say the nums array is 12, 21, 36 and so on and so forth. So we'll be first taking this number 12 and we are getting all the divisors. So let us see how we are getting the divisors. So first I have declared a vector divisors, then we are running a loop from 1 to root n to get all the divisors. Now if n is divisible by I, that means this I is a divisor of n, so we are just pushing I into our divisors vector. Now if we know I is a divisor, then we also know that n by I is also the divisor, which will be present in the later half or the values that are present after root n. So we'll be pushing n by I also into our divisors vector, but only at one condition: if this I and n by I are not equal. Because if they are equal, so why would we putting a duplicate value inside the divisors vector? So this is how we'll be getting all the divisors. Now in the end we'll be checking if the divisor's length is 4 or not. If it is 4, then we need to take the sum of all the divisors. So we'll be taking the sum and we are keep on adding into our sum variable that we have created here. So this is how we'll be doing for each and every number. So all those numbers whose total divisor are 4, we'll be keep on adding it into our sum, and in the end we are just returning this sum. So I hope you understand this particular solution. So thank you for watching.